Welcome to KringleCon 4. My name's Tom Liston. I'm a senior technical engineer and breaker of things at CounterHack. And today I'm going to do a presentation on RFC 3514 compliant pen testing. You may have heard somebody say something like this before. Sometimes there are good reasons to do bad things. As pen testers, that's kind of our motto. We're good folks, but we do bad things. Actually, if I'm out and being introduced to a bunch of new people and I'm in one of those moods, sometimes I will introduce myself to people and say that I'm a professional thief, or I'll say I break into networks for a living, or I steal data for a living, because I do. But those of us who do these things on a regular basis know that there are some rules that we have to follow. In fact, we probably have more rules that we follow personally than most people do. Even if you're doing bad things, you still need to follow some rules. Interestingly, back on April 1st of 2003, a gentleman, an amazing gentleman by the name of Stephen M. Bellevin, released RFC 3514 via the Network Working Group of the IETF. Now, RFC 3514 put forth a pretty radical proposal for the use of what was previously unused, the high bit of the IP flags field. Now, that has always been called the reserved bit because they didn't have any use for it. It was the only bit in the IP header that wasn't used. But Mr. Bellevin came up with this utterly ingenious idea in this RFC, and his idea was to provide a solution for the growing problem of malicious traffic on the internet. And this was back at the beginning of 2003. His proposal was that this bit should be set in order to show whether a packet had evil intent or not. So if you set the bit to 0, the packet has no evil intent at all. You should just assume that the packet is harmless. You should not take any defensive measures against it because this is telling you that there is no evil intent here. If, however, the bit is set to 1, the packet has evil intent, and you should secure yourself, try to defend yourself against this packet. So with this proposal, he also came up with a name for that. It was only fitting that once was this register, this bit that was once named the reserve bit, now became known as the evil bit. Now, suddenly security was easy. This was a boon for the makers of firewalls. Why would you need to do deep packet inspection? Why would you need a next generation firewall? It's simple. It's so simple now. All you have to do is look at this one bit and decide whether or not you're going to drop the packet. If it's 1, meaning that the packet is evil, drop it. Interestingly, Gartner declared the IDS dead in June of 2003, 2 months after the release of RFC 3514. Is that a coincidence? I don't think so, because why would you need an IDS anymore? Security was now easy. But maybe that isn't how it all worked out. What happened? Well, RFC 3514 was a wonderful, incredibly innovative idea, but it did not deliver on its early promises. Why not? Well, I'll tell you why not. It's because the bad guys failed to comply. And why did the bad guys fail to comply? Well, I don't think there's any question. It's because we in the security community have been setting a horrible example. My question to you is this: if you are a pen tester, if you are a security professional and you do any kind of security testing Are you RFC 3514 compliant? How do we expect others to follow the rules when we don't? The security community really needs to step up in this instance and set a good example. Well, I'm here today to help you do just that. I've created a fun little piece of Python code called evilbit.py. And well, I think it's fun. You may not think it's fun, but I think it's fun and interesting. It uses IP tables net filter queue capabilities. And then it also uses some of Scapy's packet crafting and editing magic to make your Linux box proudly proclaim its evil intent when you're doing pen testing. You can now boldly be RFC 3514 compliant. The way it works is this. IP tables net filter queue allows you to tag packets with an identifier that can then be pulled. Those packets can then be pulled out of the packet stream prior to being sent, and you can do many things with that. By using Scapy, what we're doing is we're pulling these packets in. We are altering the IP flags field to turn on the evil bit. We're then updating the checksum, the IP checksum for that packet, and then tossing the packet back into the queue and allowing it to be sent. All done on the fly, all done without any interaction with any other piece of software on your system. Your system doesn't even need to know that this is happening. All of your normal pen testing tools work just fine. All of your network connections will work just fine. All that will happen is that every IP packet that goes out will have the evil bit set. I've got a GitHub repo for this. It's down there at the bottom of the screen. It'll continue to be on the bottom of the screen for the next slide or two here. I would strongly suggest that if you do pen testing and you want to be RFC 3514 compliant, go take a look at the code because it'll really help you out in that regard. But then I'm sure there are some of you out there who are just thinking, well, I'm an antisocial buffoon who doesn't care. I don't want to set a good example by being RFC 3514 compliant while pen testing. Well, hey, if that's what you want to do, that's fine, I suppose, but I'm just going to have to say it. Shame on you. Shame on you for not wanting to set a good example. This is why we cannot have nice things on the internet. But even if you are a horrible, horrible human being who doesn't want to set a good example, far be it from me to deny you a learning opportunity. So, the GitHub repo is still there. Perhaps you might find this little example to be an opportunity where you could take a look at the code that I'm providing to you, be impressed by my incredibly amazing programming prowess. I know it's a little intimidating, but that's okay. You might want to take a look and see a little about how you could use IP tables net filter queue combined with Scapy to alter packets on the fly from, the warm, wonderful, comfortable embrace of Python. You may find that this has some other potential possibilities. I may or may not have used this kind of technique to do some editing of packets that I needed to change within a PCAP file at one point in time or another. Learning this kind of stuff, learning how you can use Scapy to edit packets while still fixing things like IP checksums or TCP checksums or UDP checksums. Really, really interesting stuff that has a lot of implications, a lot of uses in other types of activities. So take a look at the GitHub repo, or as my friend Josh Wright says, GitHub repo. And I hope you have a really, really wonderful rest of your day. I hope you enjoy the rest of your trip here to the North Pole, and that you enjoy the rest of KringleCon 4.